Okay, we are ready to talk about superconductors, but a word on conductors before that. Conductors are metals. It could also be graphite. Uh, Metals, now why do they conduct electricity? You should know from past because they have delocalized electrons or free moving electrons. One thing is true about metals is as temperature increases, the resistance to electrical conductivity linearly also increases. So this is true about conductors and metals, that as temperature goes up, the resistance to electrical conductivity increases. Now, why? There is a cause and effect. As temperature increases, the electrons, the free electrons, are colliding with the positive ions, which are your nuclei, quite often. Therefore, the electron cannot go through a straight path, and that's why resistance has gone up. Now, what is superconductors? It's really a property, the same metal, the same element that was a conductor, or its alloy or ceramics that are superconductors. There is a threshold or a critical temperature that once you cool it below that, the resistance to electrical conductivity actually goes to zero. A case of mercury, if you look at it, as temperature is decreasing, resistance is also linearly decreases, but once you get to this critical temperature, which for mercury is 4.2 Kelvin, resistance immediately goes to zero. There is a quantum leap of that. So this is what superconductivity is, when there is absolutely no resistance at that cold of a temperature. There is another property for superconductors, and let's just talk about that. There are two properties actually. So when temperature is below critical temperature, there is no resistance to electrical conductivity, and we need to justify why. Also, they repel your exterior magnetic field at that temperature, low temperature. Now, the properties are explained in this fashion. Why the resistance goes to zero? According to following scientists, Bardeen, Cooper, Schrieffer, which is BCS, they have created this theory that at low temperature, the positive nuclei, when the electron goes through, they sort of get distorted. And then another electron gets attracted. And here actually they form a couple of electrons known as Cooper coupling. So what happens if there is energy in this repulsion, this energy gets transferred to the second electron. So there is no loss and gain of electrons, energy, therefore the electron freely moves through. There is no resistance to this. That's their theory, and you should know as brief as I just explained. There's much more into it. So this is why the resistance to electrical conductivity goes to zero. To justify why there is repulsion of magnetic field, Meissonier effect, after his name, this is what he proposed. He said, look, if you're a conductor, like a metal, the electrons are all over the place, some pointing down, some pointing up. And what happens here is the exterior magnetic field just sort of penetrates through. There is no repulsion here. Now, if you're a superconductor at that temperature, the electrons are perfectly ordered, and that creates a mirror image of this exterior magnet, and then there is a repulsion. Now, this is a demonstration that's usually done in physics department in college. So liquid nitrogen is used to bring the temperature of a superconductor really low. Once that's the case, you can even float a magnet on top of it, because it has the same mirror of flux of exterior magnetic field. Now, there are two types of conductors. There is a type 1 superconductor, which are usually pure metals, and there is type 2, which are usually alloys, bunch of metals mixed. Now, when this is a picture to say, on the y-axis I have the exterior force of a magnetic field, x-axis is temperature. When the temperature is below critical temperature, there is this superconductors repel the magnetic field up to a threshold. When the exterior magnetic field is bigger than that, then it behaves like a normal metal, and the there is no repulsion of magnetic field. If you are type 2, now you have two critical magnetic field. Below the temperature, critical temperature, up to here, if your exterior magnetic field is this much, there is perfect repulsion. But if the exterior magnetic field gets bigger, it's between, let's say, BC1 and BC2, then you are behaving like a normal and a superconductor. So there is a mixture of that. Then again, we are really touching the surface of conductivity, which is usually covered in physics or electricity unit of physics, but this is the extent that you need to know as a chemistry student.